Ladies and gentlemen, welcome back to Kerbal Space Program. This is Captain Ardwick, and today we are going to go even further than we have gone before. We were in our atmosphere for the last two experiments, but now we're going to go much further. It's time to go into space. Right, so we're going to build a brand new craft today, and because we're going to go into space, I'm going to build a brand new class of craft. In honor of some of the earlier missions that predated the Apollo missions that NASA did to go to the moon, we're going to call this the Mercury Project, or the Mercury 1 is what I'm going to be using today. The Mercury Project involved several very famous astronauts who did very famous suborbital and orbital experiments to see what it would take to survive in space, and we're going to do the same today. Like last time, we're going to use our pod as the base of our project. We're going to add the essentials. We're going to add a parachute, and we're going to add some science to it too. In fact, we're going to add a little more science to it now that we can. We're going to start with the mystery goo containment units, and this time we're going to have 3 of them. So we're going to press X twice to have 3. I'm going to do my best not to have it obstruct the doorway, although that might be impossible. Let's see if we can make this work, and if we can't, then we'll fix it. So now we have 3 goo projects on it, and because we have 3 of them, we might need to have a little bit more thrust, which is no longer a problem. In fact, we're going to add a new science experiment called the the Science Junior, and plop it right at the bottom. Now, this is a very important payload that we have here, so we want to ensure that it survives. We have a new item that we got with our technology tree called the landing struts. Those landing struts are going to allow us a safe return back to the planet. In fact, we're going to add 3 of them. I'm going to put them immediately below the goo containment projects to help with stability and so on. We're just going to plop them right down there. Right, so this is our science payload right here, but we need to give ourselves some thrust. The first thing we're going to do is put a decoupler underneath all of this, so that this is the part that we want to have get recovered. Everything beneath it is going to be thrust and non-recovered. We are going to include, because we have a heavier payload, we need a little bit more power, so we're going to use a fuel tank, a big one, and plop a liquid fuel engine underneath it. This one is going to be... it's not going to give us as much thrust, and it's going to be more efficient. And by the time we use this stage, we're going to be high enough to the point where we don't need as much power. However, that implies that we're going to use yet another stage, and that is true. I'm going to raise this up a little bit, and put another decoupler. Let's see here. Another decoupler underneath the one that we have now. And it sort of fills in that slot for us, thankfully. We're going to add 2 more of these guys. That's 2 fuel tanks, and we're going to cap it all off with a liquid fuel engine. So now we have a machine that should be capable of achieving space flight. This is our first space mission, and it's going to be very fun. So let's save our progress here real quick and make sure this thing actually flies. So the first launch of Mercury 1. With a high scientific payload and a much more powerful system. The first thing we are going to do is prepare ourselves. That is to say, we're going to increase our thrust with the shift key until it goes all the way up. We are going to press the T key because we intend to go straight up and we want to have a nice stable launch. And finally, we're going to launch it. So launch us by launching the first stage. 3, 2, 1, and ignition and liftoff of the Mercury rocket, heading straight into space itself. Like a lot of the missions before, we are aiming straight up this time. We are going to try another experiment where we go in a different direction, but for now we're just going to go straight up for the purposes of this experiment. Because we have a lot of fuel between one of our decouplers and the liquid fuel rocket, we have plenty of fuel to burn, and that should give us plenty of lift. Already our acceleration is going up pretty good. We are at nearly 200 meters per second and increasing in speed. So any moment now we are going to run out of liquid fuel and our next stage will begin when we initiate it too. While we're here actually, what I'm going to do real quick is I am going to, let's see, I'm going to do a quick mystery goo experiment. I think we've already done that one, but that's okay. We now need to quickly dislodge and shoot again. So now stage 2 is kicked in, and we are going much further into space than we had before. Our speedometer is going to slowly increase back up. We lost a little bit of acceleration because we had to switch between our two stages, but now we're going back up and increasing. Because we have a big fuel container here, that means we have plenty of fuel to run, and that'll get us farther than we need to go. This might actually be more power than we really need, but that's okay. It's okay to have more power in this case. Once we reach 30,000, I'm going to do another one of these goo experiments. Almost. And here we go. Let's try this one next. It's getting rather cold now. That must mean that we're getting pretty high up, and we're still accelerating because we still have more than half the fuel in this tank right here. And now we can see the stars too. We're more or less above the atmosphere at this point, so we've actually just about made it into space. We officially hit space when we hit 100,000 meters. When we get that high, then we're officially in space. We're going to speed things up a little bit here. Yeah, I think this is definitely more thrust than we needed. I don't even think we need to be going anywhere near this high. There we go. Oh. Music's kicked in, which means that we are now as high as we can get, or... Actually, what that music means is that we are officially in space, so we made it, everybody, and we're still accelerating at a really high rate. Now that we're officially in space, I'm going to do yet another goo test right here. And it clumped into a sphere. That's important data right there. I wonder what that goo is. We haven't really the slightest idea what that could be. Wow, the planet is actually escaping from us. That's a little frightening. However, we have not achieved enough velocity to go into orbit or escape the planet, so we will eventually be returning to it. While we're here, though, there is still more science that we can still do. In fact, this new Science Junior that we equipped onto our mission also is capable of giving us some more data. Let's check it out. Crystalline structures, loose objects. Ah, that is 25 science. That is a very high count, and thus really good reason to have that particular experiment with us. We're going to keep that data. Ooh, I see galaxies over there. This is actually really cool. Let's zoom out and really sort of grasp the environment here. There's so much universe to look forward to. Before we get too sidetracked, though, let's conduct a little bit more science. We are going to conduct a crew report. We are very much in space, so there's that to consider. In fact, we're also going to try an EVA as well. He looks so excited, doesn't he? Well, it's time now for a quick EVA. We're going to right-click him, do an EVA report, 8 science, and we're going to quickly get back on board, because I think if you're out of the capsule for too long, you have the risk of floating away. Just as a note, you can press F5 to quick save. So, just a good thing to note in case you want to protect yourself. In fact, if you're actually doing an EVA, you can use your, I'll show you actually real quick. If we actually let go of the spacecraft, press the L key to light up the light on our hood, press the space key to let go, and then press the R key to turn on our jetpack, we can actually do a little bit of floating around outside of our spacecraft. I would not recommend this if you don't know what you're doing, because it's actually a little hard to control. There we go. We've actually floated a little bit above, so I'm going to use the Shift and Command keys to gently bring us back to where we need to go. We're trying to get back on board our... F, there we go, there we go. That was important. Let's see. We're going to collect data from that experiment. We're going to quickly store all of our experiments inside of the pod. Let's see, we've already done this EVA before, I think, but let me try putting it anyway. It won't let me because we've already done that one. Well, that being said, we are going to return back into our space pod before anything happens. So we're going to dump the duplicate experiment, get back on board, and at this point we are actually slowly falling back to the planet. We still have a little bit of time, and because of our time warp we can make this go a little bit faster. In fact, I believe we are going to do that shortly. We got really high up, actually. I believe we almost got twice the distance from the barrier of the surface, from the start of space, which is not bad. Probably a lot more power than we really needed for this experiment. This thruster beneath us and the liquid fuel booster is no longer necessary. It is now dead weight, so we are going to eject from that. We probably could have done that sooner, but that's okay. Let's watch it slowly fall back to the planet, gracefully having done its full duty. From here on out, there's not much left to do aside from really fall back down to Earth. We can, since we're in speed, we can actually accelerate time faster. When we were in the atmosphere, we can only accelerate up to 4 times, but up in space, we can accelerate up to 100,000 times. But first, let's pull down the throttle, because the game doesn't want us to have our throttle up while we're falling, or while we're time skipping. We're going to go forward a little bit, but when we put ourselves back in the atmosphere, it brings us back down to 1 times, which is useful to know. We're still going to accelerate a little bit more to get us down a little bit faster. There's our command center over there where we first launched from. At this point, we should probably be deploying our parachutes. Oh, actually not yet. Hold on. Now, this part may look scary. Ordinarily, re-entry is a very dangerous procedure for space travel, but apparently in Alpha, that's just for show. We are now going to, having done that, now that it's safe to deploy a parachute, we are in fact going to do that right about now. And because we have these landing struts right here, we can press the G key to activate them, which gives us a higher probability of a safer landing. So we should have done now everything that we needed to do to successfully land the Mercury 1. There we go. Let's see if we can do another crew report while we're here. I don't think we can, but no, we can't. The one we got up in space is far more important. We're going to accelerate a little bit to allow us to get back to the planet a little faster. But before we actually hit the ground proper, we are going to slow down ourselves because our shadow's catching up to us. Nearly there, and touchdown! A safe arrival back to the planet Kerbal. Is there anything else we can still do here? The answer is yes. We are going to conduct one more EVA. Oops. Sorry, I guess I let go a little bit too early. There is that risk of doing that. Let us take an EVA report. We can't really get any new data from this, but we'll save it anyway. Let's take a surface sample of the dirt, which gives us a little bit more science. It's not much, to be honest. And we're going to plant a flag to commemorate our occasion here for our first successful space venture. We are going to name this the Mercury 1 landing. first into space. There we go. And that's about as much as we can do on this particular mission. So we're going to call it a wrap on this particular one. We're going to recover ourselves, giving us a tiny bit of science, but the majority of the science is from the machine we left behind, which we will now recover. Right like this. And that gave us 72 science, the biggest yield so far, by far, quite frankly. We are done with that. And in fact, there are a couple more things we can do with the Mercury one. We are going to try to use it to go, not totally orbital, but we are going to try to land in a different location than we did before. Oops. This is mostly a test to see how far we can take this. So we are going to go back to the Mercury 1. And we are going to launch it. I have no idea whether or not this will work, but we're going to try to control our trajectory to land in a different location. If it doesn't work, we have multiple safety measures to ensure our survival. Actually, real quick on the launch pad here, what I can do real quick is actually cause the Science Junior to... I mean, we can check it out real quick. That'll give us some science right away, so if all else fails, we'll still have this. Everything else should be good to go. I am going to try to launch us further than we've gone before. So let's throttle up and go. Now, this is a vessel that doesn't have too much in terms of stability, so we're going to have to be careful on this. Don't ever aim it so slightly forward like this. Slightly now. We need to be careful because we could lose our lose control of this if we're not very careful. We're going to push T to maintain our trajectory. And if we go to our orbit map on the bottom of the screen by pressing M or by going to the button, we can see our orbital path. Oops. It might be a little bit too soon to see anything, but you notice how we sort of go into this archway right here? This archway shows us where we are going right now, and the higher up this goes, the higher up we are going. The higher up this apogee point right here, or apoasis, the higher up we're going to go. If we were to press X, that would stop our fuel from burning, and we would go no higher than that apogee point. Oh, something interesting is happening right here. In fact, we've run out of fuel, so we are going to eject from that very quickly, start our next fuel, and we are going to aim a little bit more at an angle. Aim it at about 45 degrees, and hit the T-button to stabilize ourselves. Now our orbital map is aiming us a little bit further out, like this. Frankly, I'm not sure how far we can get. This is mostly a test to see if we can get far at all. We still got a lot of fuel though, so we might be able to make a decent semi-orbit. I'm not sure what the actual term of that is. I'm going to shut off our stabilizer, aim a little bit further down this way, and re-enable our stabilizer. See what that looks like on the map? Yep, we are going much further now. We might be able to land in the mountains, actually, now that I look at it. Let's see, can we in fact make it to the mountains? Possibly. We're about halfway out of our fuel right now, and now that we're almost about 30,000 meters above the surface, let's do another crew report, because I don't think we've done one from up here yet. So, not much in the way of science, but it's something. Our fuel propellant is about to burn out, and it looks like, of course, we're not going to make a full orbit. We are still increasing our distance. Maybe if we were smart enough, we could actually hit the pole of the planet. That might be an interesting biome to check out. We might actually do it. Hold on, that's still accelerating. Not quite. I don't think we're quite gonna make it that far. We're gonna come close, though. But I think because we used up some of our fuel at an angle we shouldn't have, we didn't quite make it to the poles. Perhaps next time, though. Let's see if we can conduct any science at this height. Crew's getting cold. Okay, that's nothing new. We're gonna eject from our other stage. And we're going to speed up time a little bit. So we didn't quite make it to the pole, but we're getting somewhere close. Looks like we're going to land on those mountains if we do this correctly. So, not only can you use rockets to go straight up, but you can also use them to go sideways, and create a very long archway. In fact, our next missions will involve orbits, and an orbit is simply one of these arches that goes so far that it circles around the planet entirely instead of actually falling back down, which will be our next mission after this. But first, let's see how far we can take the Mercury 1. We are already falling back down. The altimeter is going down, and shortly we will have to make a landing. It occurred to me that it might be a little dangerous to actually land on a mountain because the surfaces there are rugged. But that's what science is for. And with a parachute, we'll at least ensure that we don't die, although we might not have a stable landing. Let us accelerate again. Oh dear, we might actually crash into the side of a mountain. Wouldn't that be crazy? I've never tried this before, actually. This could go horribly wrong. I think we're going to crash into the side of a mountain. This is bad. Before anything else happens, let us quickly deploy our parachute to ensure survival. And let us drop our Mercury 1 landing gear. There. So now we're probably not going to die, but we're in dire straits right now. I have no idea what's going to happen. Okay, so we're not actually going to land on top of the mountain. It looks like we're going to land on the base of it. I don't know what it thinks this biome is, actually. This could be interesting. Let's speed up a little bit here. Keeping an eye for a shadow. Oh dear. This looks like it's... Okay, good. I was actually worried that wasn't going to deploy. Let's try landing. This might be some useful experience for if we have to land on a planet or moon that has a lot of mountains. Okay, we are close enough to the surface where we want to land safely. Ooh, oh, there we go. Haha! Just for kicks, let's try some of our more mystery goo stuff. We observe the goo. That's about as much as we can get out of that particular one. Do we observe more goo? We do! Bam! Now, unfortunately, we've already used our Science Junior at the base, so there's not much more science to gather out of that, but we can conduct a quick EVA by doing an EVA report. It's a very precarious situation over the mountains. It does, in fact, count this as a new biome. So we are going to store the data here, quickly get back on board, see if we can do... Actually, you know what? Hold on. I am actually going to dismount. I'm going to try something new this time. Oops! Oh no! Oh well. We'll try next time. We can no longer get back on board the Mercury 1, but we can do a little bit more EVA stuff here. Spacesuit wasn't entirely necessary to arrive here, but that's okay. And we're going to do a surface sample. Ooh, rocks and snow. I didn't realize we would get this much of an interesting result here at the mountains. Nice. And we are going to plant a flag here to commemorate our occasion, the furthest yet distance from our initial launching point. We're going to call this Mercury Mountain. Derp, because I don't know what to say about it. That concludes our mission to Mercury Mountain. That might not look like much science to you, but remember, we had dislodged from our Mercury 1 capsule. And we in fact need to go recover that real quick. That's where most of our science is currently stored. There we go. That gave us 21.9 science. So the majority of our science was done with that orbital, not orbital, but that higher altitude mission. But we got to explore a new biome with that one too. With that, we can check out our current science. We now have 112. That should be enough to give us a bit more, actually. Right now we want to invest in electrics. This gives us some new items that we can use, such as panels. Those are solar panels. And a rechargeable battery bank. Useful to have, so we are going to take that. We can also take either general rocketry or stability as well. For the purposes of a high flight, we're going to want stability for this, so we're going to take some of these. And that's about as much as we can do at the moment. So, fortunately, we've gained a lot of science, gotten even further, and in the next adventure, we are going to go orbital. So, until then, everyone, this is Ardwick. Stay tuned, and good night.